Dear students, we can do some of the problems in this section, rotational dynamics. The first one, using the parallel axis theorem, calculate the moment of inertia of a uniform disk of mass 0.2 kg and radius 0.05 meter about an axis passing through its edge and perpendicular to the plane of the disk. Once more, using the parallel axis theorem, calculate the moment of inertia of a uniform disk of mass 0.2 kg and radius 0.05 meter about an axis passing through its edge and perpendicular to the plane of the disk. How can we do this problem? Here we have a uniform disk. Its mass and the radius are given. Okay. Then we are asked to find the moment of inertia of the disk about an axis, which is passing through its edge and perpendicular to the plane of the disk. Then you can imagine which is that axis. Okay, suppose we have a disk like this, and you can see here the axis, the required axis is that one which is passing through its edge and perpendicular to the plane of the disk. That means this is the disk. Okay, and we have to find the moment of inertia about this axis. That is, we have to find I. That we can do with the help of the parallel axis theorem. Okay, so for the parallel axis theorem, so we have a one more axis which is parallel to the required axis and it is passing through the center of mass. You can see and this axis which is passing through the center of mass. The moment of inertia about that axis can be taken as Ig. Now, according to the parallel axis theorem, here the moment of inertia about this axis, that is parallel to the perpendicular to the plane of the disk and passing through the edge, that can be calculated by I is equal to, from the parallel axis theorem, I is equal to Ig plus ma square. I is equal to Ig plus ma square. We are given the mass of the disk, that is m is equal to 0.2 kg and the radius is 0.05 meter. And what about A? Here A is nothing but A is the radius. Here the distance between the two axes is the radius. What about Ig? Ig is the moment of inertia of the disk about an axis passing through the center and perpendicular to the plane. So what is that? We have the formula, that is Ig is equal to ma square by 2. Okay. Now let us substitute these values. That is Ig is equal to ma square by 2 plus m instead of a we can have radius, that is mr square. So that is equal to 3 by 2 mr square. 3 by 2 mr square. Okay. Now let us substitute the corresponding values. That is 3 by 2. What is the value of m? That is 0.2 kilogram. Radius 0.05 square. So you can do the rest of the calculation and find the value of I. So that is equal to 7.5 into 10 raised to negative 4. What is the unit of moment of inertia? That is kilogram meter square. The next problem. A uniform circular disc has a moment of inertia 0.05 kilogram meter square about an axis perpendicular to the disc and passing through the center. What is the moment of inertia about an axis touching its edge and perpendicular to its plane? May I repeat? A uniform circular disc has a moment of inertia 0.05 kilogram meter square about an axis perpendicular to the disc and passing through the center. What is the moment of inertia about an axis touching its edge and perpendicular to its plane? Here, the problem is similar to the previous one. Instead of giving the mass and the radius of the disc, we are directly given the moment of inertia of the disc passing through the center and perpendicular to its plane. That means we are already given the value of Ig. Okay, so we can do this problem with the help of the parallel axis theorem. That is, according to the parallel axis theorem, I is equal to Ig plus Ma square. Ig plus Ma square. Okay, here we are directly given the moment of inertia of the disc about the perpendicular axis passing through the center. That is, Ig is already given. That is 0.05 kilogram meter square. Okay. Now we can do then we can find the moment of inertia about the perpendicular axis passing through the one of the edge. So that is I, that is equal to. But do we know what is the equation for the Ig? That is, we are already stated in the previous problem. That is Ma square by 2. Here also M instead of A, we know instead of A what is that is here A is equal to radius. So instead of A we can write R square. Okay, that is equal to 3 by 2 M R square. Okay, and again let me write 3 into M R square by 2. Okay, even though we are given the value of Ig directly, but we know the expression for the Ig. The expression for Ig is equal to M R square by 2. Okay, about that is the value of Ig, that is expression. So instead of M R square by 2, we can substitute the value of Ig, that is 0.05 kilogram meter square. So that is, you can substitute instead of M R square by 2, that is instead of the value of Ig, we can have this value 0.05. So what is the value? That is we can do the calculation. That is 0.15 kilogram meter square. Now move to the third one. A disk has a moment of inertia 1 kilogram meter square about its axis. If it is rotating at a speed 2 revolutions per second, find the torque required to stop it in 5 rotations. A disk has a moment of inertia 1 kilogram meter square about its axis. If it is rotating at a speed 2 revolutions per second, find the torque required to stop it in 5 rotations. Okay, I think the problem is clear. Here we have to find the torque required to stop a disk which is already rotating at a speed of 2 revolutions per second. So how can we do this problem? First we can find the an expression for torque tau is equal to I alpha. Okay. So we are already given the moment of inertia. Here the value of I is given, that is 1 kilogram meter square, and we don't know the value of alpha. Okay, alpha is the angular acceleration that we can find using the equations of rotational motion, equations of motions in the rotation. Okay, so for that we can which formula we have to use? We can use the formula omega 2 square equal to omega 1 square plus 2 alpha theta. This is the required formula that we can use to find the value of alpha. So what are the values of theta? Here theta is equal to, we have to stop the disk within 5 rotations. That is, we know for the one rotation the angular displacement is 2 pi. So for 5 rotations the angular displacement is 2 pi into 5, that is 10 pi radian. Okay, then we have one more term, that is omega 2 0. We have to stop the disk. What about the omega 1? We are given the rotating speed in frequency, that is 2 revolutions per second. 2 revolutions per second. So what is the angular velocity? 2 pi f, that is 2 pi into 2 revolutions per second, that is equal to the 4 pi radian per second. Okay, now we can substitute and find the value of alpha. So what is alpha? Alpha is equal to omega 2 square minus omega 1 square divided by 2 theta, that is 0 minus omega 1, that is 4 pi square divided by 2 into 10 pi, that is equal to 4 pi, that is negative 16 pi square divided by 20 pi, that we can make this some cancellation. We can 1 pi can be cancelled, and here that is 4 by 5, negative 4 by 5 pi, that is radian per second square. Now this is the alpha. Now what is the torque? The torque tau is equal to I alpha. So what is I? I is equal to 1 kilogram into, here we are using the magnitude of, we are taking the magnitude of alpha, so that is 4 by 5 pi. So you can complete the calculation. So the answer is 2.51. What is the unit of torque? That is Newton meter. Okay. Now the fourth one. An iron disc of radius 1 meter has a thickness 1 mm. Find the moment of inertia about a diameter. Density of iron is 8000 kg per meter cube. Repeat. An iron disc of radius 1 meter has a thickness 1 millimeter. Find the moment of inertia about a diameter. Density of iron is 8000 kg per meter cube. Okay. Here we have an iron disc. An iron disc, the moment of inertia about a disc, moment of inertia of a disc about a diameter is given by, we have the formula, I is equal to m r square by 4. That is 1 by 4 mr square. And we have the radius. R is equal to 1 meter. And we don't have any value of mass. Instead of mass, we are given the density of iron. And we know the dimensions of the iron disc, that is the radius and the thickness. From that, we have to first find the value of mass. So, since the density is given, we have to use the concept about the density is equal to mass by volume. So, from that, density rho is equal to mass by volume, or mass is equal to rho into density into volume. So, what is the value of volume of the iron disc? The volume of the iron disc, that we can do area into thickness. That is equal to rho into pi r square into t, the thickness. We are given the value of thickness, that is 1 mm. That is 1 into 10 raised to negative 3 meter. That is the unit. So, the moment of inertia I is equal to, instead of m, we can substitute rho into pi r square into t. Okay, that is the value of m, and r square divided by 4. Okay, so let us rearrange rho into pi r raised to 4 into t divided by 4. Now you can do the substitution. You can do the substitutions, that is rho is equal to, what is the value of rho given? Rho is equal to 8000 kilogram per meter cube. So 8000 3.14, radius is 1 meter, so 1 raised to 4 into the thickness, that is 10 raised to negative 3 divided by 4. Now you can complete the calculation. So what is the answer? That is, the answer is 6.28 kilogram meter square. Okay. Now the fifth one. A disk of moment of inertia 12 kilogram meter square gains an angular momentum 384 joule second in 8 seconds starting from rest. What is the torque acting? A disk of moment of inertia 12 kilogram meter square gains an angular momentum 384 joule second in 8 seconds starting from rest. What is the torque acting? What is the torque acting? So we know what is the relation between torque and angular momentum. The torque tau is equal to the change in momentum divided by the time. That is the rate of change of angular momentum, L2 minus L1 by T. Okay. So we are given the moment of inertia of the disk is given, that is 12 kilogram meter square, and the initial angular momentum L1. Initial angular momentum L1 is equal to 0 because it is starting from rest. So initial angular momentum is equal to 0, and the final angular momentum is 384 joule second, and the time for obtaining this angular momentum is 8 seconds. So the torque tau is given by, we can substitute the values. This 384 minus 0 by the time 8 seconds. Okay. So please complete the calculation. And the answer is 48 Newton meter. 48 Newton meter. Okay. Now the sixth one. A circular disk of mass capital M and radius capital R is set rolling on a table. If omega is the angular velocity, show that its total energy is 3 by 4 mr square omega square. Okay. A circular disk is of mass m and radius r is set to rolling on a table. If omega is the angular velocity, show that the total energy is 3 by 4 mr square omega square. Okay. So we have a disk which is rolling on a horizontal table. So it has a capital M is the mass and a capital R is the radius. As the disk is rolling, as we have already studied, it has both a translation and a rotational motion. Okay. So as the disk is rolling, since it has a rotation, so it has an angular velocity omega, and it is translation motion. So as the disk is rolling, here the center of mass, we are considering the motion of center of mass. The center of mass has the displacement, with a velocity v. So the circular disk possesses both translation and a rotational kinetic energy. So the total energy is equal to rotational kinetic energy and plus translational kinetic energy. Okay. Now let us check. So what is the rotational kinetic energy? The rotational kinetic energy is given by half I omega square. And the translational kinetic energy is given by half m p square. Okay. So we have to express the total energy in terms of angular velocity. So first, in the case of rotational kinetic energy, as the disk is rolling, the disk is rotating about an axis perpendicular to this plane and passing through the center. Okay, so the moment of inertia about that axis is mr square by 2. Is mr square by 2. That is half into mr square by 2 into omega square plus whatever the translational kinetic energy. So we have to express the velocity in terms of omega. So we have the relation V is equal to R omega. Okay, so instead of V, we can substitute this value. So half m R square omega square. Half m R square omega square. So that is 1 by 4 m R square omega square plus 1 by 2 m R square omega square. So what is that value? When we add 3 by 4 m R square omega square. Okay. Now this is the total kinetic energy of the disk when it is rolling on a table. Okay. Thank you.